In this video, we will talk about volumes. Now, volume is a very important concept we need to understand. Now, we will be talking about several concepts in this video, specifically why we need to study volumes and the concept behind volume basically. And then we'll be studying how to calculate volumes for different objects. In this video we'll be concentrating mainly on how to calculate volumes of cubes and cuboids, okay, and then we'll be talking about the unit of volume. Now let's start with, we'll be first starting with the concept of volume first, okay, why we need to study volume and what actually volume is. Now let's say when we draw something, like we saw these shapes in our daily basis, like the squares, the circles and triangles. Now one thing is very common among these shapes are when you draw them in a paper, right, in a piece of paper, that paper we can think of it as a plane, and the squares, this circle, this triangle, or any object which we can draw on a paper, we can thought of that particular shape is actually lying on that paper itself. It never comes out of the paper. Suppose if we keep a piece of glass on a paper, that glass is coming out of the paper, correct? But these shapes like the squares, the circles, the triangle, it never comes out of the paper. That is one thing. That's why you call these shapes as 2D shapes, okay? So they do not occupy any space. One thing we understood from here, they don't occupy any space. Now think about this one. Let's say we have a cylinder filled with water, okay, a jar, cylindrical jar, or we can say maybe in your daily life we have seen drums, right, some portion of it filled with water. So the current water level is here. Now let's say we have a cubical shape. Let's say it's a cube. We play ludos with cube, right? So let's say we have that one and we throw inside this one into this water. So what happens? We saw the certain portion of the water level goes up here, right? No, this is an interesting fact. When we throw that cube inside that water, the water level goes up. But similarly, if we just throw the squares we draw in a paper, the water level will not go up because the square do not occupy any space, but this cube occupy a space here, okay, and the water rises the same amount. So if we'll be able to calculate this volume of this water, okay, which is going up, that means the volume of the water present in over here, so it will be same as the volume of this cube, okay. So this is an interesting fact. That means the cube is actually displacing the same volume of water. So that's why to make space for this particular cube, the water level is going up here, right? So similarly, if you see in lot of objects in our daily life, like a ball we play with, right, like a cone, this shapes, everything takes some space here, correct? We called it solids. When we will be going to the next level or higher classes, you will be seeing lot of stuff about solids, okay, but I just introduced that term. Don't be confused. But the main thing is that whatever shapes we are discussing here, all of them takes space, and we call them as 3D shapes because of that one, okay, and they all occupy space. Now this is where the concept of volume comes into picture. The amount of space they occupy is called the volume. There is nothing else. So this is very simple stuff. The amount of space consumed by a 3D object or a solids is called a volume. And what kind of objects we can consider as 3D? Whatever you are seeing in a real life world, let's say a computer CPU, a laptop, everything, okay, which you cannot draw on a paper. You can draw it, but it is a projection of that image. It is still 2D there, okay, because it does not consume any space there. But whatever you are seeing in a real life, a house, everything is a 3D object here, Okay, so hopefully the concept of why the volume we need to study is clear now. Now if I just see the real life usage of volume, we can think about this one. When we go for refueling of our car, right, we talk about how much volume of fuel we need to put inside our car tank, correct? Similarly, when we cook food, we ask about, for a particular dish, we ask about a amount of oil in terms of teaspoons, right? Like 2 teaspoons of oil, 3 teaspoons of oil, something like that. So there also we talk about the volume of oil there. So let's talk about how we can calculate volume. Now there is and while doing that, we will be talking about mainly on cubes and cuboids in this video. Maybe in the latter videos we'll talk about some more fun stuff there. Now before we go to that level, let's understand what do you mean by a unit cube. Then this whole concept will be very much clear there. Let's say we have a cube there whose length is 1 centimeter, breadth is 1 centimeter, and height is 1 centimeter as well. Okay, now our job is to find the volume of this cube. So this cube is basically called a unit cube because all of its sides, because for cube, what do we mean by a cube? It has 6 faces. If you see this is the face number, this is the face number 1. So if I just write it down, so this is my face number 1, this is my face number 2, this is my face number 3. Now this below there is a face which is nothing but our face number 4. Behind there is another face which is nothing but our face number 5, and there is a face over this side as well which is nothing but our face number 6. So we have 6 faces in a cube, and each and every face has the dimensions are same here. If you see, this is also 1 centimeter, this is also 1 centimeter, even this is also 1 centimeter, this is also 1 centimeter. That means each and every face is a square face, and that means the dimensions are same for that particular face, and it has a 6 faces. Okay, that's a cube. And when we talk about unit cube, that particular dimension is 1 of any unit. It could be 1 centimeter, 1 meter, anything. Now if we just try to calculate the volume of this guy, so we can think of it something like this one intuitionally. Okay, so let me draw this one. Let me draw a cube, whatever we are seeing it here. Okay, maybe I'll try to draw in a better way. I'm not drawing in a scale, so it could be something. So this is our lower face, if you see it. So this is 1 centimeter, even this is also 1 centimeter here. Now we can think of this is a square, right? This is a square, and we can think of lot of squares on top of each other, right? There could be another square, something similar shape, okay, on top of each other, something like this one. So it will goes on till we are getting 1 centimeter height, right? So that means we have so many squares if we just stack one by one. So let's say we have so many squared plates, correct? Now if we just stack them one by one unless we are getting a 1 centimeter height, so we will get a cube there, correct? So that means each and every, we know the area of a square, correct? That means its length into breadth, and as both are same, that means it's basically length squared or breadth squared there. That means the area is area of each square, area of each square is 1 centimeter into 1 centimeter, correct? And we are with this, all this area, we are reaching a height of 1 centimeter. So that means the volume of this unit cube will be this area. That means area into that height, right? Because we are reaching that 1 centimeter height over here. That means 1 centimeter into 1 centimeter into 1 centimeter, correct? So that means we can think of volume as how much material we need to build this build this cube as well, correct? That is another way of thinking what volume is, correct? So that means, so if we just talk about the volume of this cube, so it is 1 centimeter into 1 centimeter into 1 centimeter. So 1 cubic centimeter we say. Now with this concept of unit cube, let's solve a real world problem of finding the volume of Rubik's cube. So I think most of you saw this particular game. This is very interesting and you should try this one. This is called Rubik cube, correct? Now let's assume that this side of each of these smaller cubes are 1 centimeter. Okay, so for this white surface over here, this white and this red, this is a single cube, right? So all of this surface, this length is 1 centimeter. That means as we saw for cubes, each and every side is same length. That means all of this length will be 1 centimeter only. Similarly for this orange faced cube as well, it is 1 centimeter here. Okay, similarly for this blue one as well, 1 centimeter here. So that means we are talking about a collection of unit cubes here, correct? We saw in the previous slide, a unit cube is a cube where each and every dimension is 1 centimeter or any one unit there, centimeter, meter, whatever it is, correct? So that means if we know, now think about this one. So if we just tell you how many unit cube we are finding there, so let's count it. For the upper layer, we let's count it. So you have 3 in this one. That means 3 plus 3 plus 6 plus 3 is 9, correct? So for the upper layer we have 9. Something similarly like this one, so like this layer we have another 2 layers, correct? So that means 9 plus 9, 18 plus 9. So we have total 27 of cubes here, correct? And all of them we saw, as we have assumed, that the length of their side is 1 centimeter. So that means all of them are unit cube. And we know the volume of each unit cube is 1 cubic centimeter, correct? So that means the volume, the total volume of this whole Rubik cube will be, there are 27 unit cubes. That means 27 into 1 cubic centimeter. That means 27 cubic centimeter here, correct? Now very interesting, let's see that one. Let's see, if you see it here, this 1 centimeters length actually making this whole Rubik cube length 3 centimeter. Similarly, as this is all our unit cube, that means this will be 1 centimeter as well. These are all will be 1 centimeter. Even this one will be 1 centimeter. Okay, this is red, so let's like this one, even 1 centimeter here as well. So that means my breadth will be 3 centimeter as well, and my height will be 3 centimeter as well, correct? Okay, so that means, and very interestingly, if you just multiply these three guys, this 3 centimeter length, 3 centimeter breadth and 3 centimeter height, we are getting 27 cubic centimeter as well, which is nothing but the volume of the Rubik's cube. So that means if we just multiply the length, breadth and height of this cube, or any cuboid, we'll see in the cuboid example as well, we will get its volume. Because if you see it, when we talk about a 3 centimeter, correct? So that means we can, if we just, because for our units cube, the length, breadth and height all are 1 centimeter. That means if we are just wanted to place unit cubes here for a 3 centimeter side, I can place maximum of 3 unit cubes here, right? So 1, 2 and 3 unit cubes, correct? Similarly for breadth also, as it is 3 centimeter, we can place maximum of 3 unit cubes, and for height also, as it is 3 centimeter, we can place maximum of 3 unit cubes here, correct? And that's why it is total 27 unit cubes here as well, 3 into 3 into 3. For length we have 3 unit cubes, and how much breadth we have, 3, that means these 3 unit cubes will be repeated 3 times. That means that's why 3 into 3 into 3, correct? 9 cubes we are getting for this layer. Similarly, we have for height we have 3 layers, that means 3 into 9, 27. So that is how that we are getting total 27 number of cubes here. Okay, now let's talk about cuboid. Cuboid means nothing but a shape, a rectangular box you can thought of, okay, where the surfaces are not cubes, it is rectangles. That's it. For cubes, it was everything was cube, right? So if I just go to the previous slide, for Rubik's cube, all these surfaces are cubes, right? For cuboids, you can thought of all these surfaces are rectangles. That means this one is a rectangle, this one is a rectangle, like this. Okay, even this one is a rectangle as well. Now if you see it like shape wise, it is almost similar, but the thing is that here the length, the breadth, the height are not same, which was the case for the cube. It was all same, right? Even though we constructed a bigger cube here with these Rubik cubes, still their length, breadth and heights are same because it's a cube. But for cuboid, it is not same because this is not a cube, this is a cuboid. Now how we will find the volume here? So we saw for Rubik's cube we were basically having small unit cubes to help us, correct? And we also saw if we just multiply the length, breadth and height, we are getting the volume of the Rubik cube as well. So let's say whether we can construct any unit cube here or not. Okay, then we will verify with length, breadth and height formula, which is the shortcut one. So if I just try to construct unit cubes here, so as we saw, when we saw the Rubik's cube length, it was 3 centimeter, we were able to construct maximum 3 unit cubes, because for unit cube the length is 1, that means 3 divided by 1 is 3. So that means for the 5 centimeter we can create maximum of 5 cubes here, something like this one. I will try to draw it properly. Okay, something like this one. I'm not drawing in a scale. 1 2 3 4 5, we can place maximum of 5 cubes here. As for breadth wise, we will be having maximum of 2 here, correct? So I'm trying to draw in a better way. And this height wise as well, we can have maximum of 3 cubes here. So if I just draw these shapes, okay, and here as well as here. Okay, I'm not drawing in a better way, but I think you got the idea. So we are basically constructing smaller unit cubes here. So all these unit cubes has 1 centimeter over 1 centimeter of with height and breadth over here, right? So that means now if I just ask you how many unit cubes we are having it here, in that first layer, we are in this place we are having 5 unit cubes, and that means, and that too we have total 2 layers, that means 5 into 10, 5 into 2, that means 10 unit cubes, and we are having total 3 centimeter of height, that means 10 into 3, that means total unit cubes we will be having is 30 here, correct? And as we know, for each and every unit cube we are having the volume of 1 cubic centimeter. That means we are having the volume, total volume of this particular cuboid as 30th cubic centimeter, and which is nothing but same as 5 into 3 into 2 centimeter here. Okay, so that means if we just talk about a general formula of volume of any cube or cuboid, we can directly, if we have the length, breadth and height of that particular solid, we can directly multiply them all together to get the volume of that cuboid or cube here. So hopefully we got an idea about how to calculate the volume. And if you see, when we talk about cuboid or cube, the approach is same here. Okay, we just need to multiply the length, breadth and height. And why we need to do that? We have taken 2 examples. In that Rubik's cube, it was apparent that that unit cubes are present there, but in this cuboid we actually make it, we need to draw this one, and then we understood, okay, then we can make actually any structure, any cuboid structure as small collection of small unit cubes. Then you just need to call, we just need to basically count that how many unit cubes we can create there, then we can write the volume there. Or that's for the concept wise. But if you, in your exams generally you need to mainly concentrate on what is the length, breadth and height of that particular cuboid or cube, then just multiply them all together. Okay, now let's talk about the unit of the volume. So as it is very apparent over here, so it is nothing but the cubic centimeter here, right? Cubic centimeter. That means sometimes we can, if you are going for the higher level, higher classes, you may be able to see centimeter cube, something like this one. Okay, and when the unit of that length, breadth and height is centimeter, then only it will be becoming centimeter cube, because you are multiplying this centimeter into centimeter into centimeter. Okay, so this thing you can write cubic centimeter, okay, or centimeter cube as well we can write. Now when we talk about a separate unit of the length, if you see, I have used meter over here, right? So that means the volume will be 30 meter cube instead of centimeter cube, because the unit of the length is meter over here. And how I got 30? Because I just multiplied 5 into 3 into 2 there, correct? So this is what, and if you see, if you talk about real world cuboids, there are a lot of stuff like the gift box, correct? The microwave. These are all the real world examples of cuboids here. So hopefully this video was helpful. Let me know if you have any questions. You can put in the comment section of this video. I will try to answer them as well. Okay, see you in next video.